Welcome to another video from the Cool Tech channel. Please subscribe to our channel and press the notification icon to get notified in future videos. In the following video, I will show you how I managed to trigger two types of external cameras to capture better time-lapse videos while using the Octolapse plugin for the Octoprint. All the information and settings that I found to work best for my setup. You might need to test and come up with better settings that will work best for you. So see this video as general information. By the way, if you want to learn how to set up Octoprint on your Raspberry Pi to control your 3D printer, I will make a video on this in the future, so don't forget the notification icon. So if you install the Octolapse plugin, you have the option to use the cameras which can be connected to your Raspberry Pi, which are supported cameras that connect to the camera port on your Raspberry or by USB using webcams. All those cameras don't have very good video quality, so your time-lapse video might not look as good as you probably want. I was looking for a way to trigger external cameras while being synced to the 3D printer layers. So we are using the Raspberry Pi as the printer controller, and we have the GPIO pins which we can connect to. Depending on the type of camera you have, there are few ways to trigger. I will show you two ways. We have infrared remote control and the remote control of any kind with a button, such as this one from YAI, Bluetooth. So little more details on both ways. I will show you how I done both of them. So first of all, infrared control. If your camera has a remote control by infrared option, we can use the Raspberry Pi to send signal to infrared LED, such as this one, to trigger the camera. For example, I will use this Sony Alpha 6000 mirrorless cameras, and it will act as if I press the shutter button. We can also, the second way, is to add a relay to the Raspberry Pi to make the relay to close the connection on any other remote control by hacking its button. I will use this Bluetooth remote from YI 4K camera which I had. So the step of setting up Octolapse and creating the Python and Bash files is the same for both triggering way. The only difference is the script themselves and the IR LED or relay connection. So let's begin by installing the Octolapse plugin on the Octoprint. Go to Settings, next Plugin Manager, and then search for the Octolapse plugin and install it. I have already installed it. After you finish all the install, let's close this one. Next, go to this Octolapse tab and let's begin the configurations. You need to create a new profile. In the printer tab. So I have the Creality CR10 printer. You press this add profile, fill the name of your profile, description if you want, the company which makes it. You need to fill all these details and save. I already done it for my Creality CR10 printer. Then we need to go and create a camera profile. Go to Camera tab, and same here, click the Add Profile button, and here you need to create a new profile. I will show you the profile which I created for both of the ways. Here you can see G-code camera built into printer. Let's see what setting I used, and I will explain. Let's see. You need to choose the profile to import the G-code camera. Camera type is external camera script. This is the field which I will show you how to create the bash script, and then we will test it. All the other parameters are not so important right now. I will explain them also later. Now let's go, and I will show you how to connect the infrared LED. So first I will show you the schematic how to connect the infrared LED. You probably have an old remote controller lying somewhere that you don't need or don't use it. Then you will need to get an infrared for this. I used an old infrared remote that I don't need anymore and just desoldered the infrared LED out. Next you will need a 220 ohm resistor, and as you can see in the schematic, what you need to do is to solder the resistor to one of the legs of the infrared LED, doesn't matter which one. Then you connect the negative pin of the LED to ground pin on your Raspberry, which is pin number 6, and the positive one into GPIO pin 40, which is the last one. Next is the tricky part. Depending on your camera maker and model, you need to find the trigger signal code. In my case, I am using the Sony, as I said, Sony Alpha 6000 camera, so a little googling, I found the infrared code for it on the web. I will add a link into the Python code which I used so you can use it. This is not my code, so the full credit is to Gordon77 who posted it. Next, we need to SSH into our Raspberry. In my case, this is the IP address and this is the port. Open it. If it's the first time you're connecting, you need to approve the security message. Enter your username and password. Okay, let's see what we need to do now. Change directory into the scripts directory by entering this command, cd scripts, and here you can see all the scripts which I made. We will check this one, which is called trigger Sony.py. It's Python code. So let's see what it looks like. Okay, so this is the code which I copied from the link which I will post in the description. You just copy the code here, and the most important thing is to note is the out pin. In my case it's GPIO pin number 40, which I told you. So just change this number into the pin number that you have, which is 40. All the rest can be left as it. You save the script by pressing Ctrl S and exit by Ctrl X. We need to create another script, which is a bash script. That means that the Octoprint will be able to execute it. So what we need to do is again sudo nano, and let's call it trigger script Sony.sh. Enter, and here it's only one line, Python space, and then trigger Sony.py, which we created previously. Again, Ctrl S to save, Ctrl X to exit. And now we need to change the execution rights for this file. So just execute this command, chmod +x, and the path to the bash script. Enter. That's it, we're done with the files. Now let's get back to the Octoprint. And here you have the external camera setup script, as I said before. So just enter this path to the file which we created before. Okay. Now what we can do is to test the script. And here you can see that when I test the script, listen carefully, you can hear the camera is shooting. Okay, so this was the first way. Next, what you want to do is to save the settings. By the way, you can add the delay here if you will see that your camera is taking too long to shoot the frame and you need to add a little delay before the next layer of your printed part is being done. You can add here delay in milliseconds. Like if you want 1 second, you enter 1000 milliseconds. Okay. Save it. And this was the first option as infrared LED. Now let's go into a second option, which is the Bluetooth remote controller. So for the second option, what you will need is the Bluetooth controller and 5 volts relay. I will add a link in the description below. Here you can see the schematic which I trying to draw. The VCC pin of the relay, it will go into pin number 4, which is the 5 volts. The ground will go into pin number 6, which is the ground, and the in, which is the signal, will go into pin number 40, which we used before also. Now what we need to do is to set up the script. As we did before, what you need to do is to SSH into your Octoprint, enter your credentials, okay, let's see what is the code for this. Again, we need to cd into the scripts folder. Let's see which files I have here. We will create this file which called trigger.py, call it whatever you want, sudo nano, enter your password, sudo. Okay, this is a short code, you can see it here. I will post the code into the description of this video. Just copy the code here, save it by Ctrl S and exit by Ctrl X. So again, I forget to tell you, we need to change the pin number into 21. In the code which I will post, it's already 21. 21 is the different naming of the pins. We have the GPIO pin and we have the BCM pin. BCM is number 21, which is the same as GPIO 40. Okay, so let's create the bash script, which is called triggerscript.sh. Should look also simple as this: Python space path to the file and trigger py, which we created previously. Save by Ctrl S, exit by Ctrl X. Okay. So as you can see here, I connected the relay to the Raspberry Pi in the way that I showed above. The in to pin 40, the other one is plus 5 volts, and the ground. Now the relay connected to the Bluetooth controller, which I hacked, and I will show you how I connected to it. And you can see when I execute the script, the relay gets triggered and the remote is also reacting, if you can see, like this. And if I sync the Bluetooth controller to my phone, it will also shoot. Let me show you how I connected it. It's a little bit messy, but doesn't matter, it works. After you take out the button, which I just cut with a knife, you can see two connections which I just solder into, and the relay is just closing the contact as if I press the button. Okay, simple as that. As I showed before, if you want to change into the Bluetooth controller, you go into camera, edit the profile which you created, and just change the script into what we just created. If you have any kind of errors, you go into logging. Let me show you. You go into logging, and then you will have the plugin Octolapse.log. You download this file and you can see if something is going wrong. So that's all. Test it yourself, play with it. Let us know what you think about this video in the comment section, and if you found anything interesting, so we will update. What I want to show you another thing is that in the profile you have all this section of the custom camera script, G-code script. You can search the web and find all kind of G-code scripts which will move your stage or your print head into different locations before and after the frame, so it will look like the part is growing on your printer bed, which is kind of cool. But I didn't find the best setting for my printer, and I got very bad stringing, so need to play with it. And another thing, that if you don't want to take Octolapse time-lapse while you're printing, don't forget to disable your plugin, or your printer will stop in each layer and it will take much longer to print. After you finish shooting all your images, they will be combined of many single images. You need to combine them into video. I will add a link in the description into some software which I found from Microsoft, which is very easy to combine all these images into video. So check the link in the description section. So thank you for watching this video. Please subscribe, let us know what you think in the comment section below. Also press the notification icon so you won't miss our future videos, and be sure to check our channel, as I will be posting a lot of time-lapse videos in the future with my mirrorless camera, and also with my new iPhone 12. You will see what results you can achieve using these much better cameras and what you can add to your Raspberry. So thank you again, see you in the next video.